COVID-19 has been the most pressing issue in current times across the globe. Due to the massive impact COVID-19 has had on our lives and the risk it poses to our health, medical professionals have worked tirelessly to obtain more information on the virus to make the world safer. We wish to contribute to this noble effort through our project. Because COVID-19 has varying symptoms and requires significant time for medical professionals to diagnose, we hope to enhance the accuracy and efficiency of COVID-19 diagnosis and reduce the time and error involved in diagnosing the virus. By developing two diagnostic models trained on distinct data sets, this project hopes to evaluate the accuracy of machine learning-based diagnosis and further understanding the relative importance of various types of diagnostic data. Our first model will be a convolutional neural network trained on a dataset containing labeled chest X-rays. This dataset contains X-rays from COVID patients, but is relatively small. However, it has been used to successfully train an image classifier in a previous study. Additionally, we have a much larger dataset containing only X-rays from healthy individuals and patients suffering from non-COVID diseases that can be used to supplement our data. To make up for this class imbalance, we will use class balance focal loss when training our network. For our second model, we plan to implement a support vector machine that will be trained on a dataset with 8 binary features specifying symptom and demographic information for each individual, as well as their COVID diagnosis. This dataset has also been used for training in previous machine learning research. We hope to achieve high diagnostic accuracy with our first model, the convolutional neural network. However, we may run into the issue of lacking a sufficiently high volume of data for training. We hope using X-rays of patients suffering from other diseases will help us improve our data. We have high confidence in our second model since the data sets are large enough for us to implement a support vector machine for the purpose of determining COVID diagnosis from various symptoms. A clear application of the models trained in this project is immediate deployment to identify COVID-19 in symptomatic or at-risk individuals. Beyond the pandemic, the models developed can also be extended to aid in the diagnosis of other flu-like viruses through methods such as transfer learning by using chest X-rays or a list of provided symptoms. The available data sets present potential difficulties for supervised learning. Due to the small size of the chest X-ray dataset and the low dimensionality of the symptom dataset, it is difficult to train a model to generalize to all cases. In addition, validating the model's performance will be more difficult as there will be less data to test with. Despite these challenges, we believe the dataset we have will yield viable models and a feasible project. Additionally, we have included links to each of the 3 datasets mentioned in our proposal. Thank you.